The science behind popcorn popping. Popcorn pops due to the moisture inside each kernel. Each kernel has a small amount of water trapped inside a hard, outer shell called the pericarp. When the kernel is heated, the water inside turns into steam, building up pressure as the temperature rises. Once the pressure exceeds the strength of the outer shell, the kernel bursts open, and the starch inside rapidly expands. Heat and moisture interaction. As the popcorn is heated, typically to around 180 degrees Celsius, 356 degrees Fahrenheit, the moisture inside the kernel turns into steam. This steam creates pressure within the kernel, causing the pericarp to become soft and eventually rupture. The heat also causes the starch inside to gelatinize and puff up, turning into the airy, crispy structure we recognize as popcorn. The role of the kernel's hard outer shell. The hard outer shell of the kernel, known as the pericarp, plays a crucial role in the popping process. It acts as a barrier that holds the steam inside, building up the internal pressure until the kernel finally explodes. The outer shell is strong enough to withstand the pressure, but it eventually cracks open, allowing the starch inside to expand rapidly into a fluffy, edible form. Starch expansion during popping. Inside each popcorn kernel is a small amount of starch. When the kernel heats up, the starch absorbs the moisture and swells. As the steam pressure inside the kernel becomes too much for the pericarp to contain, the kernel ruptures. The starch then expands quickly, turning into the puffy texture of popcorn as it cools and solidifies. Why some kernels don't pop. Not every kernel pops because each needs the right combination of moisture and heat. If a kernel is too dry, the water inside can't turn into steam, and the kernel won't build up enough pressure to pop. Similarly, if the kernel is damaged or its outer shell has a crack, it may allow the steam to escape before enough pressure builds up, preventing it from popping properly. The popping process in different environments. Popcorn can pop using a variety of methods, such as in a microwave, on the stove, or using a hot air popper. Regardless of the method, the basic principle remains the same: heat builds up steam inside the kernel until the pressure forces the outer shell to burst. The specific temperature and heat distribution may vary depending on the method, but the core science behind the popping remains consistent. Pressure and temperature control in popping. Popcorn requires precise temperature control to pop correctly. If the heat is too low, the kernels won't build enough pressure to pop. If the heat is too high, the kernels may burn before popping. Typically, the ideal temperature for popping popcorn is between 180 degrees Celsius and 190 degrees Celsius, 356 degrees Fahrenheit to 374 degrees Fahrenheit, allowing the steam to create enough pressure to cause the kernel to burst. The explosive expansion of popcorn. When the kernel finally pops, it expands rapidly from a small, hard shape into a light, airy puff. This sudden expansion happens so quickly that the starch inside the kernel sets in its expanded form, creating the fluffy texture. This transformation occurs within milliseconds, resulting in the characteristic shape and texture of popcorn. Popcorn's physical properties after popping. Once the kernel has popped, the starch cools and hardens into the airy, crunchy texture we enjoy. The expansion causes the kernel to increase in size by several times, with the inside turning into a spongy foam. The popcorn's texture is both light and crisp, making it a popular snack around the world. The fun and fascinating popcorn process. Popcorn's transformation from a small kernel to a fluffy, edible snack is a fun and fascinating example of food science. The pressure from steam, combined with the kernel's outer shell and inner starch, creates a magical process that results in the satisfying pop we all know and love.